military. Just remember, you're being recorded. And I get the recording for class you did after you guys today. Lucky you, right? How you doing?
Not.
No spill. Maybe a little bit. But no spill.
That's a good bird.
Huh?
Good bird. Hey guys, go ahead and take care of fire for me if you don't mind. And then we're going to get right into our discussion for today. We're in Unit 3 now. Congratulations. Okay. That wonderful algebra unit that we've been in since, October or whatever is over. Okay? So we have made it through. So I'm going to pass out your assessments too. Okay? Get these chairs down and you guys get going and then we'll get going here because you have an assignment to do tomorrow. All right? So we need to make sure we get it done then. Get these down so everybody can see. You guys have a good weekend? Enjoy the nicer weather? Good, good, good. Passing around your assessments, okay, guys? Blades, yours. Get Abby's here while we're here. There you go. So I get those back? There we go. There we go. You're welcome. Okay. I'll go over it. If there's anything you want to talk about, whatever, I'm available after class. Just let me know how I can best help you, okay? All right, guys. Do you remember way back when it was really warm outside, back in August, when we were first getting to know each other? We did problems like this where I gave you a square root and you had to tell me what centimeters it was. You don't remember those problems like that? Well, I'm going to refresh your memory here just a little bit, okay? So let's take a look at a problem similar to that. So here's what we did. Let me just pull up a blank note just for fun here. Okay. So what we did was we took the square root of 68, kind of put it in the middle here. And then what we did was we drew a number line from one end to the other. Does that sound familiar now? Okay. And then we put a square root here and a square root here. And the idea was to find a perfect square number that was just less than 68 and one that was just after 68. Okay, sounding familiar now? What was the perfect square number that was just less than 68 that we would use in this case? Abby? 64. Yes, good. Okay. Yep, so we put 64 here on this side. Who can help me out with the one on the other side? Give me a hand, please, Blaze. 81. Excellent. Okay, good. Now, what is the square root of 64? 8. What's the square root of 81? 9. Now, we also went a step further on this and said to the nearest half integer, right? So halfway between 8 and 9 is 8.5. Does anybody know what 8.5 squared is off the top of their head? Anybody? There's a trick to get this real quick. You know what the trick was? It's 72.25. Mm-hmm. Here's the trick. You take 8 and 9, your ends, multiply them together. What's 8 times 9? 72, right? Then all you have to do, because 0.5 squared, 5 squared is 25, right? So 0.5 squared is 0.25. You just tack on a 0.25 at the end of it. And that's how you get your halfway square root. Okay? Works every single time. I don't know why. It's just one of those mathematical things that just happens. Okay? So, where's this go? Is it closer to 8, 8.5, or 9? Okay? It is a little bit closer to 8 by 0.25. Okay? That's how we did this. Okay, way back in August when we were just starting out on this interesting year of stuff, right? Okay, now you know how sometimes you watch a show on TV and a character that you haven't seen for a while makes a comeback, and it's like a cliffhanger, and you're real excited about it because you weren't expecting it. Well, guess what? Square Root's going to make a comeback today. Okay, they're back. You guys don't seem like excited, like if it's a cliffhanger or anything like that. I see lots of nods and like I hear virtual groans. A lot of virtual groans today. Okay. All right. Well, we're going to try to knock this out today in class, so then we're in a good place to do your assignment tomorrow. Then, okay. So, in your email on Friday, okay, I sent you a notes template for this lesson, so you can have some interactivity with it. Okay. So go to your email. And open that note file Notability. And if you need help with that, let me know. I'll be glad to help you. Okay? In the meantime, I'm going to go there myself. It should look something like this, except the P3W. Okay? Right here. Okay? If you can't find it, raise your hand. Let me know. I'll be glad to help you with it. Everybody get it? You can use the PDF. It's on Canvas if you can't find it. But if you can, you know how to share it. No, it's not an assignment. It's from Friday. Yeah, that's the one. Scroll down to the bottom. There's the, keep going. There's the attachment. Open the notebook. Okay, everybody have it pulled up? Show me a thumb if you're ready to go. Excellent. Okay, so here's what we're going to do. All right? Okay, your first task is to work in your groups. Okay, we're going to just do a little experimentation here. What I want you guys to do for me is look at problem number 1. I'm going to give you a square, okay? And I'm telling you that the area of that square is 50 square units. Okay, 50 square units. What I want you guys to do for me is determine how long a side of that square is. Okay? And I want an exact value. I want an exact value here. Everybody understand directions? So in essence, what I'm asking you guys to do for me is determine the length of this side right there. Okay? Can you do that for me? All right. Talk about it with your group mates. Again, I want an exact answer. Okay? So talk to your group mates. I'm going to be about a minute or so, minute and a half, and then I'll ask for an answer from each group. Okay? So turn and talk. I'm going to come around and eavesdrop a little bit. Okay? Go. All right. Blue group, you guys have an answer you agree with? Okay. Green group, you guys have an answer you agree with? Yellow group, you guys have an answer you agree with?
No,
You have an answer that's the majority that agrees with.
we don't have any.
You don't have an answer yet. Well, you got 30 more seconds to come up with something. Okay? 30 more seconds or so. I want to know what the length of the question mark is. Okay? What value is that question mark? Okay. So, I'm going to start coming around here. You guys continue to figure it out. Okay? I'm going to you guys last over the yellow group. Okay. Blue group, what did you guys say the answer was? 12.5. Okay. Green group, what did you guys say the answer was? 12.5. All right. Yellow group. You said 12.5 also? Okay. So now you know what I'm going to ask, right? How'd you get 12.5? Okay. Trevor, how'd you guys get 12.5?
Well, I said, at first I put 25 all the way around.
Mm-hmm.
I said, no, it's not right.
Okay.
Then I divided 25, divided by 2. Yeah.
Okay. All right. Okay. Blaze, how'd you get 12.5? Okay, so you decided 50 divided by 4. Okay. All right. Yellow group, something similar over here? Okay. Pretty much? Yeah? Okay. All right. Now, I have a question for everybody. Okay. How do we find the area of a square, or for that matter, just any kind of rectangle or parallelogram for that matter? How do you find the area? What's the formula for that? Adam? Now, when you're finding perimeter, you do add up all the sides to get the perimeter, but I'm asking for the area. I want to know how much space is within the boundary, okay? Not the distance around the outside, okay? So how do I figure out the area inside? You want to take another guess? What do I multiply together? All 4 sides together, or just 2 of them? Okay. Length and width, right? Base or height. Okay. Now, here's the deal. This is a square. I told you this was a square. So what do you know about squares? Okay, Maddox says that there are 4 congruent sides. All 4 sides are the same length. That means that length equals width, right? Okay, so that's actually what you need to have for a rhombus. There's another criteria you need to have that makes a rhombus also a square. Does anybody know what the other criteria is? Okay, because a rhombus is a quadrilateral of 4 congruent sides. Okay, a square has that also, but it has one other additional criteria that has to be met. You know what it is? That's the same thing you just told me.
I don't know.
Okay. Has something to do with the angles.
Right angles.
All 4 angles are right angle. All 4 interior angles are right angles. Class, what's the right angle measure? Perfect. So you guys do remember that. Awesome. Okay. So, what? As what? For a square it is, yes, but not for other polygons. Okay. All right? Because other polygons, the interior angles, if they're all the same, have different measures. Okay? So, those are criteria for a square. So, in this particular case, then, if I change the question mark here and make it, let's just make it x, okay? Then what's this side up here have to be at the top? X. And then what Adam said was, you have to multiply those together to get the area, right? So what's x times x? Remember your exponent rules. Don't get fancy. That's x to the first times x to the first. X to the second power. X squared. Does that make sense? Okay, go to number 3 and put that in. Okay. So, x squared. By the way, we're going to be skipping around a lot here on these, okay? Now, okay, let's figure this out. Because if 12.5 is the right value here, if I square 12.5, I should get the area. We know the area is 50, right? Does that work? Is 12.5 squared equal to 50? Try it. What's 12.5 times 12.5? What's 12.5 times 12.5? That's what you told me the length was.
Oh, wouldn't it be 50?
Would it?
No, it's 156.
A lot more than that, isn't it, when you square it?
Oh.
Okay, yeah. So 12.5 is not the correct value for the length of the side, right? Okay, so hold that thought. We're going to do a little bit other work. We're going to come back to that. And hopefully by the end of the period, you will know what the correct value is. Okay? Fair enough? All right, let's go to the next page. Okay? And let's do some experimentation here. So on the next page, okay, you should see this green tile here on the side. Ever have that green tile? You can move that and duplicate it and whatever you need to do if it'll help you solve the next problem here. Okay? So what I'm going to ask you to do is, let's say that you have a square and the area is only 4 units. Okay? What would be the side length? Okay? Now, I just hold on a second here, okay? This square right here on the board, this green square, is what we call a unit square, all right? The length and width are both 1, and so is the area, because 1 times 1 equals 1, all right? So you can use this manipulative here to make a square and verify what you just told me, or you can do other math, okay, and verify what you just told me. But right now, groups need to work together and come up with a value for a side length of a square that has an area of 4 square units. All right? Take a minute or two and get busy. Go. Okay, talk together. I'm going to come around to get an eavesdrop. What's that?
What was the question again?
The question is, how long is the side of a square with an area of 4 units? Okay, 4 square units. How long is the side length? Thoughts? What's the side length of a square if the area of the square is 4 square units? How long is that side? Raise your hand, help me out here. Anybody? I heard Maddox say 2. Agree or disagree with 2? Give me a thumb, yes or no? Do I have a square up here that's an area of 4 units? If each of the small green tiles is an area of 1 unit, then I have 4 of them together. That's an area of 4, correct? Okay. How long is the side length then? If that's a 1 and that's 1, that's also 1, right? Here and here. What's that become? 1 plus 1? 2. All right. What's another way you could have gotten that? What were your thought in your head? Because the sides have to be the same, right? So what number times itself equals 4, correct? What number times itself equals 4? 2. All right, good. Now, let's do something different. Let's do it on number 6 here. Does that actually work out with the formula? Okay, remember our formula is A equals x squared. In this case, our area is 4. And we're checking to see if 2 works, correct? Whoops. I don't want to change it just yet. So we're checking 2. Okay. Is 2 squared equal to 4? What is 2 squared? 4. So 4 equals 4, and it does check, correct? Good. Let's repeat the exercise real quick. Okay. This time, I want you guys to tell me the area or the side length of the square for an area of 16 units. Okay. So if the area of your square is 16 plus the side length. Okay. Talk about it in your groups. Come up with one answer. Okay. Go. Be prepared to explain it. Okay. On your finger, show me what you think the side length is. On your fingers. What number times itself equals 16? The correct answer is 4. Nice job. 4 squared is 16. 4 times 4. Okay. Good. All right. So again, it works out with the math also. I put it in the formula. Okay. So we have A, whoops. On number 9, A equals x squared. So we have 16, and we're checking to see that equals 4 squared, right? What's 4 squared? 16, so it checks. We're good. Okay. So does everybody see what's happening here? Okay. If I know the area, how do I get a side length? What's happening? What am I trying to figure out? Abby? Yeah, exactly. Okay. So I got another little test for everybody now. Okay. We're blazing through this. This is great because there's a lot more time to work on your homework assignment a little bit and go over a couple of things on it. All right. Look at number 10 here. Okay. Look at number 10. I have a problem for you, and I've worked it out 2 different ways. Okay. What you guys need to do is put on your math detective hats and tell me who did it correctly. Okay. So here's the deal. We have a square with an area of 30 square units. Okay, so the area is 30 this time. Okay, so Janice solved it one way, the formula, to try to get the length, and Mark solved it another way to try to get the length. Okay, what you guys have to decide in your group, is who solved it correctly and why. Okay, and what was the other person's mistake? All right, so only one of them solved it correctly. Who did it? All right, explain your reasoning. Okay, talk with your group mates. I want to have an answer in about 1 to 2 minutes. Go. Okay. All right, yellow group, you guys got it figured out? Green group, you guys have an answer for me? Blue group, you have an answer for me? Okay. All right, you guys are showing your thumb who's correct here? You're ready to explain it? All right, on your thumb. If Janice did it correctly, thumbs up. If Mark did it correctly, thumbs down. Show me. All right, everybody have 9 thumbs down. Okay, good. Who can tell me why Janice is wrong? Why is Janice wrong, Addie?
Because if you multiply.
Okay, all right, so you worked backwards then. Okay, you saw that if you square this number, you get 15, you get 225, okay? And that's not equal to 30, which is a definite mistake, okay? Abby?
Janice divided 30 and x squared.
Okay, yeah. So here's the deal. We have to know when we're solving this equation how to solve it for x, because that's what you're going to have to do on your assignment, all right? So this is what happens typically in my class. Some students think that because the exponent on x is 2, that you divide by 2. Okay? But what they don't remember is that you're not multiplying by 2, you're squaring. Okay? Squaring is different than multiplying by 2. Okay? With one exception. Squaring is different than multiplying by 2. Okay? So we have to figure out what operation undoes squaring a number. All right? You know how if you want to undo subtraction, you what? You add, right? When you're solving an equation. If you want to undo division, you multiply, right? So if you want to undo squaring a number, what do? What's the opposite of squaring a number? Well, you solve that at the beginning of class today for your fire up assignment. You don't divide, you take a square root. Okay? Squaring a number and taking a square root are opposites. They're just like addition, subtraction, multiplication, division. They're opposites. Okay? So if you have to get this x by itself with no exponent, okay, then you have to take the square root of each side like Mark did. Is everybody okay with that? Now, is 30 a perfect square number? Is there an integer times itself that equals 30? No, there is not. Okay? That's why Mark left the answer as the square root of 30. He did not go forward with that at all. Okay? Because that is the exact value for the side length when the area is 30. Does that make sense? Okay? Try this on your calculators real quick. Pull up your calculators. I want to show you why this works, okay? So we get the calculators up for a second. So you can see how the math works on the calculator. You're going to take the square root of 30, so put that in however you know how to. Okay, so if it's 30 square root, do it that way. If it's 30, then there's square root of 30, then do it that way. Okay? Some people have to do the square root button first, some people have to do 30 first. Okay? Now don't equal anything, nothing. Okay? If you put 30 square root in times, then do it again. Okay? Then hit equal. Okay? And it should equal 30. Because you didn't change the square root, it multiplied the exact value of that square root, which is irrational. Okay? It doesn't have an end, it doesn't repeat by itself. And you got an actual integer of 30. Okay? That's how this all works out. You see how that goes? Patty? On yours, it's a little bit different. You're using Desmos. So you're going to type it in as a statement. So you're going to just do a little bit outside the radical times square root of 30 again. There you go. So what does this tell us? This tells us then that when you take the square root of a perfect square number, in this case x, or a perfect square value, that the square root cancels out the square. Okay? Leaving you with x. That's it. Are you okay with how this became a square root of 30? Good. Now, go back to problem 1. Okay? Think about this for a minute, okay? Now, we know 12.5 is not correct, but what is the correct value now? Maddox claims the square root of 50. Agree or disagree? Right? Then take square roots of each side. Those cancel out. X equals what? Is it the perfect square? I don't believe so. So then 50, square root of 50 is the final side length. Everybody see how that works? So what you're going to have to do on your assignment is you're going to have to solve these equations now, like this area formula, okay? And get values that might result in your answers being square roots, okay? That you don't simplify or don't get in a decimal approximation for. That's fine, okay? If you solve your equation and you can't simplify your square root, you leave it as a square root, okay? Everybody see how that works? All right, we got one more page here to do. We'll take a look at it real fast, okay? All right, so I have an equation, x squared equals 14, okay? On problem 13, I had started to solve the equation for you, all right? All you have to do is tell me the value for x that goes on the blank, okay? Can you do that to me? Or for me? What value of x goes on the blank? I already did the solving step for you, okay? These cancel out, like so. So what is the value for x? What value goes on the blank? Place one there now, okay? And then you're going to turn and talk. And again, we want the exact value for x, not an approximation. Okay? All right, turn and talk. You got to figure out if you guys got this one right. 30 seconds, go. What's the exact value for x that goes in the blank? All right. I think I talked to everybody today. Abram, what do you think goes in the blank? We talked with your group. Would you agree with what they said? You're not sure? You want to delegate somebody on your group to help you out with this one time? But then they get to return the favor another time. Okay? Maddox is volunteering. Is that okay? Maddox, what do you think goes in the blank? Which is what? Well, what value is that? What number, when squared, equals 14? Wouldn't it just be the square root of 14? Doesn't that follow the same pattern we've been doing? Yeah. Okay, that's exactly right. Okay, good. Now, I have a question for you guys. Or I have a little thing I want to ask you guys here. Okay? Does anybody in here know what the fundamental theorem of algebra is? If I said that, do you guys know what I'm talking about? I'm not expecting you to know, right? It's not like your mathematical life in this class depends on it if you don't know it yet. You're going to learn about it a lot more in algebra too, okay? But here's the idea, just real quickly here, all right? The fundamental theorem of algebra allows us to determine how many solutions an equation has, okay? Check this out. You look at the highest exponent on your variable. In this case, what's the highest exponent on my variable, class? What's the exponent on my variable? 2. So guess how many solutions this equation should have? 2 solutions, okay? If I have an equation like x to the 7th equals 43, guess how many solutions for x I should have? 7. All right? If the equation is something like x to the 5th equals whatever it might be, how many solutions should I have? 5. So You can tell how many solutions an equation has based upon the highest exponent on the variable. Okay? That's interesting news. Okay? Because now I can use it to help me out. But, ladies and gentlemen, I have a problem now. You guys know what it is? You just told me how many solutions this equation is supposed to have. How many is it supposed to have? 2. Oh, I only have 1. So there's another value out there in math land. It's also a solution to this equation. Okay. Anybody care to guess what it might be? Abby?
Like 3 point something. 3 and 4.
Okay. All right. We're just taking guesses right now. That's all. Okay. I just want to hear what you're thinking. Blaze, did you have to and then decided not to? Okay. 3.7. All right. Anybody else want to venture a guess of what it might be? We got one answer, it's square root of 14. I'm just looking for the other one. I mean, Trevor? 14 itself. Okay. All right. Well, let's put this to the test, okay? Let's see if anybody has a correct one. Let's work a similar problem. Remember this one, x squared equals 16, that we did before? Okay. How do I solve that equation? You take square roots of each side, right? Square root the left, square root the right. Those cancel out. X equals the square root of 16. Now, question. Is 16 a perfect square number? Is it? You have to know what your list is. Okay? It is. What is the square root of 16? 4. So when you can go the extra step and simplify it to an integer, do so. Okay? But if it doesn't simplify to an integer, you can stop right there with your square root. Okay? So we know x equals 4. But I know that x equals something else. Right? There's another solution. What is it? Turn and talk for a minute or two. Figure it out. What other value is the solution to this equation? X squared equals 16. Okay? Turn and talk. Experiment. Okay, I want to come by and hear some good stuff. Go. I want to know what other value besides 4 is the solution to the equation we just solved. Okay? What is solution number 2? All right. Any thoughts? Trevor?
I said 8.
You said 8. Okay. Hold on to that thought. Anybody else have any thoughts? Abby?
Q squared 4.
Well, 4 is the one we already have accounted for. Okay? We already have 4 right here. Positive 4s are so we have so far. Okay? Trevor said 8. 8. Can you help me go through that, Trevor?
Well, I'm not really sure any good. I just did 16 divided by 2 or
Okay. Well, we debunk that divided by 2 doesn't work before. I think we did. Remember, whatever value for x you get when you square it has to equal the original value. 4 squared is 16, right? So there must be another value when you square it, you get positive 16. Anybody figure out what it is? What do you think, Abby?
I don't know.
Anybody else? What do you think? It's kind of like an escape room. Like the code to get out of the room on time is to tell me the other value that makes this equation true. Okay? You have 5 minutes. That's not the correct one for this equation, Maddox, and it's not the correct one for the previous one either, unfortunately. Okay? Sorry. All right, think about it. Okay? What other number, when you square the number, equals 16? That's the question. We already have 4 accounted for. Positive 4. All right? Abby? She had her hand up, and then I'll talk to you, Maddox.
How was it 2 next to a 4 number?
2 to the 4th is 16. And that's not right, because we're only winning the square. Not to the 4th power. Okay? That's not what we're looking for. Maddox? Can you prove it?
Yeah, -4 times -4 is positive, negative times negative, positive.
Oh, so you're saying that -4 times -4 is positive 16?
Yep.
Oh! Hello. That might be what we're looking for. What do you think? You guys forget about those negative numbers? Don't. Okay? They're still in play. But we have to be careful how we write this, okay? I also gave, if you guys read the problem, I gave you a clue in here. You see the clue opposites attract? Okay? So, x equals 4 and -4. Okay? So, what's the other value that makes the first equation true? Besides the square root of 14? Negative square root 14. Okay? Now, the negative sign goes on the outside, does not go inside. Okay? That's the other value right there. Okay? Everybody see how that works? So when you solve these equations on your assignment for tomorrow, you're going to have to give me 2 solutions when it says solve the equation. Okay? But here's the deal. If you know the first one, the positive one, the second one is the opposite. So if you know positive 4 is a solution, guess what? Negative 4 is also a solution. Okay? If you know that positive square root of 14 is a solution, guess what? Negative square root of 14 is the other solution. Okay? Just write down the number you're given that you found and its opposite. That's all you have to do. All right? That's it. Manageable? Let's go look at the homework for a minute, okay? Go through a couple of things and then we'll cut this off. So I'm going to go back here to Canvas for a second and bring up the assignment. Here we go. Okay, check over a couple of these. So these first 6 here that's going to pop up here hopefully very soon. We'll see. Hopefully. There they are. Good. These are like the square problems, okay? You're just finding a side length. So I only need one solution for this. Can the side length be a negative number? Can you look at the square be negative? No. That's an actual distance. It can't be negative, okay? So for the first 6, I only need one value, all right? Now, starting with number 7 and going from 7 to 15, these are your equations, all right? So for example, for number 7, this is where you would do what? How do you get x by itself? You take square. You take square what? 1 out of 9 no's? I don't think so. You take square. There you go. I'll take a third. That's fine. Okay. You do square roots, right? So I'm doing 7 because it's not assigned to you. Okay. So take square. Oops. Sorry about that. Now I need to erase this. There we go. Well, I've lost my pen. All right. Well, what would be the square root of 36? 6. Okay. So then what's the other solution? Negative 6. All right. Now, for problems like number 10, okay, you can't just solve that right out of the gate for x because there's a 2 in front of it, correct? You have to still use your solving steps to get x squared by itself first. So it's 2 times x squared equals 30. So what would you do first to get x squared by itself? Divide by 2. Yep. You get x squared equals 15. Okay. And then you can take square roots of each side. All right, see how that works? Okay. And likewise for 13, okay? Get rid of this positive 5. What would you have to do? Subtract it, right? Yes, Mr. Ayers. Yes, Mr. Ayers. Okay. You're right, Mr. Ayers. Okay, so you only have to do the evens for tomorrow, okay? 2 through 18 even. That's it. You don't have to do them all. All right, we are done. Okay? See you guys on Wednesday.